This video will demonstrate how to determine the hydrate formula using lab data. Just like in the last video, the first thing we have to do is determine how much water was lost. So starting with the mass of a hydrate and heating it so that we are left with the anhydrate, we can determine the mass of water that was lost through heating. The next step we have to do is convert the mass of the anhydrate to moles and the mass of the water to moles in order to set up a mole ratio. This mole ratio will show us how many water molecules are present in the hydrate for every one ionic compound. When we determine this mole ratio value, it will tell us the coefficient of the water that will be placed into our formula for X. Let's take a look at this example. 10.5 grams of barium chloride hydrate is heated. Oops, let me make that smaller. 10.05 grams of barium chloride hydrate is heated, and 8.57 grams of anhydrate is left. These are the two values that I need in order to complete step 1. So the mass of the hydrate, 10.05 grams, minus the anhydrate, 8.57 grams. I subtract these two values to determine the mass of the water that was lost due to evaporation. And that value is 1.48 grams of water. Step 2, I convert the mass of the anhydrate to moles. So my anhydrate mass from the problem was 8.57, let's label that, 8.57 grams. To convert this to moles, I need to determine the molar mass, which means I need a formula. So going back to the problem, my salt, my anhydrate salt, is barium chloride. So I look these elements up on the periodic table, and I know this is ionic, so I have to do the crisscross method. Barium is in group 2, so it has a +2 charge. Chlorine is in group 7, so it has a -1 charge. When I do my crisscross method, I come out with BaCl2. And I need to have my formula correct in order to determine the molar mass of 1 barium plus 2 chlorines, which comes out to 208.23 grams. The unit that I start with is the unit on the bottom, and 1 mole goes on top. Alright, and I plug this into my calculator. 8.57 divided by 208.23 equals 0.0412, keeping track of my significant figures. Then I repeat the process for water. The mass of water that I calculated was 1.48 grams. And to convert this to moles, I need the molar mass. 1 mole over 18.02. Whoops, let me get my 2. 18.02, okay? 1.48 divided by 18.02 is 0.0821. keeping track of sig figs. Okay, the last step, moles of water divided by moles of anhydrate. So 0.0821 divided by 0.0412 comes out to 2. And this 2 is the coefficient of water that I will put in my formula. The formula of the salt we've already determined is BaCl2, and then my dot, the coefficient I just calculated, and then water. So my formula is BaCl2 dot 2H2O, barium chloride dihydrate.